All right, we're live. Finally, it's working. Okay, here we go. Cinco de Mayo. I love it. 5/5/22. Anybody gonna do anything for Cinco de Mayo tonight? Cinco de Mayo? Axel, anything for Cinco de Mayo tonight? Anything for Cinco de Mayo tonight? Selena, nothing? All right. Camille, Cinco de Mayo? I'm going to celebrate. Yeah. Okay, so back to math. Okay, objective. Today what we want to talk about is, we're going to talk about trapezoids and kites. Because they are quadrilaterals that are not parallelograms. They're not. They're like the cousins in the quadrilateral family that you don't want to hang out with because they're odd. They're not parallelograms. Okay? So what do we know about a trapezoid? Well, it's a quadrilateral with one set of parallel sides. And I'm going to draw one again. I've got this template that draws nicely for me, so I'm going to put this one here. This one's a pretty good one. I like this trapezoid right here because it's not isosceles, okay? Okay. I like this one right here. It is a parallelogram because these two lines are parallel, so it's a trapezoid, but these two sides are not equal. So it's just a basic trapezoid. That's it. There's nothing special about it. Diagonals not equal, angles not equal. It's just a four-sided figure with one set of parallel lines. It's pretty boring. It's nothing special. But if we make it an isosceles trapezoid, then we get some things that happen. Okay, we get some properties. Okay, am I going too fast? Let you catch up for a second. So now, if it's an isosceles trapezoid, then it's simply a trapezoid with equal legs, right? And the legs are the sides, okay? So let me go ahead and draw that in. So here's an isosceles one. Hopefully you can see the difference between the two, okay? First figure is a trapezoid. The second one is also a trapezoid. That's also a trapezoid. They're both trapezoids. And that's a trapezoid. The difference, though, is just simply this. This side is equal to this side, and that's what makes it isosceles, okay? Why? Well, the cool thing about the isosceles trapezoid is there's a couple of different characteristics we get. First of all, what we know is, one, the first thing we know is that base angles are equal. I'm going to draw it again so I can mark it. Okay. Base angles are equal. So I know that this angle here is equal to this angle here, and this angle here is equal to this angle here, okay? Base angles are equal. There's one more thing I know about these. If it's an isosceles, comes down to that key word, if it's isosceles, I know one more thing, one more special characteristic, and that is that the diagonals are equal. Diagonals are equal. All right. So that means, let me draw in my diagonals. If I drew my diagonals, I would do this. Draw them in. So My diagonals are equal. I'm going to label this. It's just easy if I label it. I'll go A, B, C, D. So I can say that AC is equal to BD. Okay? Kind of cool. That makes it easy. If it's just a regular old boring trapezoid, nothing. Nothing special. But if it's isosceles, we get a couple of characteristics. Okay? Now, kite. My template does not draw a kite, so I have to try and draw a kite on my own. They're kind of hard to draw, but it is a quadrilateral, four-sided figure, quadrilateral with two sets of equal consecutive sides, with equal consecutive sides. So let's see if I can draw. Let's see if I can draw a kite. Okay, let's see if I can draw a kite. So let's see. I'll go here, here, about there. Okay, there, there. Okay, that should do a kite. All right, let's see here. Here's a kite. Okay, there's a kite. Here's my kite. If you guys were lucky enough to be born without cell phones, you'd probably go out and buy a kite and fly it and be fun. And then what we know is, first of all, the special characteristics. We know the diagonals, like you put the sticks together, like you're putting it together, you're a kid, you're having fun, you put the sticks together, and that's perpendicular. That makes sense if you're building a kite, right? So diagonals are perpendicular. Okay, one, we know that diagonals are perpendicular, 90 degrees, right? Okay, that's one characteristic. Okay. Oh, hold on, I'm gonna do this. Put that in there. Okay. What else do we know? Well, these angles. Let's go A, B, C, D. We know these opposite angles, only these though, that angle, we can say angle B is equal to angle D. Okay, these two angles are equal. I'm going to mark my figure. Okay, that's angle, and it looks equal, doesn't it? But not A and C. These don't even look equal, right? But A's been bisected and C is bisected, and that's a characteristic the book doesn't show. But here's the second thing: is I know that that angle A and angle C are bisected. Looks like it, doesn't it? Cut in half. Doesn't that look like it was cut in half? And that was cut in half, but not these two. Angle B was not bisected, and angle D was not bisected. Okay. Are these two figures parallelograms? No, not at all. So if you look at this grand tree, I'm going to give you the family tree. You guys ready for the family tree? The family tree looks like this. You got a quadrilateral, just plain old quadrilateral. The most boring shape of all. This is the family tree. If you have a quadrilateral, you're going to have two brothers. One brother is a parallelogram. Parallelogram, okay? Sorry, sloppy. And if it's a parallelogram, then you could also have a rectangle. You could have a rhombus. And you could also have a square, right? That's that family, right? So if you're a square, you're a rhombus. If you're a square, you're also a rectangle. If you're a rectangle, you're also a parallelogram. That's the family. Now the other brother, two other brothers. One is a trapezoid. And the other is a kite. And that's all of our quadrilaterals. These are the parallelogram family. They're kind of cool. These are the oddballs. They're just the kite and the trapezoid, okay? All right, so you ready to turn the page? I'll wait for you, okay? So when you get this question like, is a, for instance, you get these all the time. You get these on your, when you guys take the state test, they'll say, is a trapezoid parallelogram? Is a square a parallelogram? Is a parallelogram a square? Sometimes, but not always, right? Is a rectangle a square? Sometimes, but not always, right? Does that make sense? Yeah. Is a trapezoid a parallelogram? Never. Okay, turn the page. Here we go. All right, so let's take a look at this problem. Okay, this is a classic. You're going to see a problem just like this on Tuesday. Just like this. So let's figure it out. If it's a kite, let's think. I want you guys to use your brains. I know you have them. What's the first thing we know about a kite? Perpendicular. So let's go 90 degrees here. Everybody agree? Put 90 there. Everybody agree with that? So I want to find all the missing angles, okay? Good. Now, do we know anything else? Okay, good. B and D are equal, right? So if this is 58, this is also 58 degrees right there.
You also know that bisects, so that's another 24.
Awesome. I agree with that, Scott, totally, okay? Now, what about the rest? Well, how many degrees are in a triangle? 180, right? So if I'm just going to highlight this. If I highlight this blue triangle here, right? And I know that's 90. I could probably find this angle here. I could find angle ADB. ADB. I could find ADB. Watch. ADB. I can find that angle, right? Just looking at the blue triangle, I know 180, so I can go, okay, I can go 180 degrees minus the 24 plus the 90. Does that make sense? I want that angle there. I've got my blue triangle. I know a triangle is 180 degrees. So if I add 90 and 24 and subtract it from 180, I should get that angle, okay? Hey, TJ's here.
Hold on.
I've got notes somewhere right here. If you want to borrow these, we're halfway through them. So if I go 180, thank you, minus, did you get 6, Scott? I believe, okay. 24 plus 90, no, I believe you, okay. 66, so I know that this angle then is 66 degrees. And then this angle has got to be 66. Okay, can you do this on Tuesday?
Yeah.
Now what about angle C?
You do the same thing with 58.
Yeah, you can do the same thing with 58. So I can do angle DCA. DCA. Let's see, DCA. I'll do it again. Watch. DCA is this angle here. And I'm doing the same thing. I'm going to go 180 minus my 58 plus my 90, right? I'm going to do that. So you're going to have to do this on Tuesday. It's not difficult. You can do this. I have faith in you. Minus parentheses 58 plus 90, and I get an answer of 32. So that means that this angle is 32 degrees, and so is that angle, because that one's bisect. Okay, thumbs up. Can you do this on Tuesday? Good. Should be easy. You just got to go back to what you know about triangles. Okay. Example 2. Am I going too fast? Okay, I'll pause for a second, let you get caught up. All right, example 2. Isosceles. So if it's isosceles, I know this angle is equal to that angle. Base angles are equal. If it's isosceles, well, that's easy. I'm just going to set them equal to each other and solve for the value of x. So I'm going to go 10x plus 4 equals a 5x plus 24, right? So if the two angles are equal, base angles are equal, set them equal, let's solve. You guys can do this. This is not hard at all, is it? So minus 5x minus 5x. I get a 5x plus 4 equals 24. Minus 4 minus 4. I get a 5x equals 20, right? Divide by 5, x is 4. But that's not the answer. We're getting close, but what's our question? What's our question? Our question is to find all interior angles. All right, well, I've got x equals 4. What should I do?
Plug it in.
Yes, plug it in. So I take the 4 and plug it in. How about right there, okay? I'll go 5 times 4 plus 24. 20 plus 24 should be a 44 degrees, okay? All right, so that's 44 degrees there. That means that angle's got to be 44 degrees, okay? How about B and C? How do we find B and C? Well, how many degrees are in a quadrilateral? How many degrees in a quadrilateral? How many degrees in a square? How many degrees in a rectangle? 360. Every quadrilateral is always 360. Always. So we know that we've got 360 degrees, right? So I'm going to take my 360 degrees and I'm going to subtract 44 plus 44, okay? I'm going to do that and then use my calculator. See what I got, okay? So clear that on, clear. 360 minus my 44 plus my 44, and I get an answer of 272. But these two angles are equal. Aren't B and C equal? So what should I do with the 272? Yeah, divide that by 2. If I divide that by 2, and then I'll be able to, okay, divide by 2, and I get 136. 136, okay? And these two angles will be supplementary. But that's an easier way for you guys to understand. It was the 360. You guys agree with that? But these two angles will be supplementary, 180, 180, okay? All right. Trapezoid mid-segment, okay? So a mid-segment is the average of the bases. Okay, so let me give you a picture, okay? Just draw a picture. It's got to be a, okay, it could be any trapezoid. It doesn't really matter. It could be, it doesn't have to be an isosceles. Let me just draw any old trapezoid here. Draw that over here. Oh, I'll draw it right here, okay? There's my mid, why, that's a mid-segment, right? Mid-segment in the middle, okay? Mid-segment. Okay, that's a mid-segment because that's the midpoint. Okay, that's a midpoint, and that's a midpoint. Okay, I'll give you a second to get caught up. That's a midpoint, that's a midpoint. Base 1, base 2, okay? So the formula just says this. We want this length for the mid-segment. It's just going to be base 1 plus base 2 divided by 2. Gives you the mid-segment. And I'll give you a second to get caught up. So it's super easy. And we saw that example in our journal. We did it in our journal. Showed you that one with really easy numbers. So the numbers I showed you in our journal were 4 plus 10 divided by 2 gave me 7. That's all I did. That plus that divided by 2 gave me that, okay? But I can also do this with algebra, okay? So if I do this with algebra, it's the same thing. I'm going to go base 1 plus base 2, base 1 plus base 2 divided by 2 equals my mid-segment. Okay, I'll let you take a look at that, okay? So I have base 1 plus base 2 divided by 2 equals my mid-segment, okay? How am I doing? Well, let's see what we can do to simplify this. So I get 8x, huh? Yeah, you're way ahead of me, Scott. Plus 28 divided by 2 equals 6x minus 4, right? Totally right. Let's just divide it by 2. Totally agree, Scott. 4x plus 14, right? Okay. Minus 4x. Okay, I'm running out of room, but I'll put it up here. I'll have a 14 equals a 2x minus 4, right? Just brought up there. Plus 4 plus 4, 18 equals 2x. Divide by 2, x is 9. But that's not the answer, because we're going to plug it in, right? So let's plug it in. Let's take the 9 and let's plug the 9 there, there, and there, right? So we're going to have a 2 times 9 plus 22. Oh, 18 plus 22, is that 40? Probably. 18 plus 22 is probably 40. Yep, 40. So this side is 40. I'm going to write that down. Okay, this side is 40. Okay, this is going to be this one? No, I'm going to go 6 times 9 minus 4, which that's 30, that's 54 minus 4, right? Which would be 50, right? 54 minus 4 is 50. And that one's probably 60, right? Probably 60. 6 times 9 minus plus 6. Let's see, we've got a 72 plus 6. Let's see, 6 times 9 plus 6. 60, there we go. Yep. Had to be 60, because you can see the average, right? You can see the average. 40, 50, 60, has to be. Yeah, 6 times 9 is 54. I think I said it wrong, didn't I, Scott? Okay, what do you think? Easy? Okay, pretty easy. All right, so stop recording. Okay, stop recording.